Hello, the given question is from test series 2 and this is control system question and chapter is frequency response analysis and this is 2 marks question. So here they have given the phase margin of a system with an open loop transfer function g of s is equal to s plus 1 by s square, which is nearly equal to a 25 degree, b 50 degree, C 75 degrees, D 100 degrees. So in order to find the phase margin of this given system, we have to follow certain procedures. So here are the common procedure to calculate the phase margin of the system. First we have to calculate the omega g by equating it to the magnitude equation to 1. Next is we have to calculate the phase at omega is equal to omega g, that is gain crossover. This is gain crossover condition, and therefore next step is the formula, that is phase margin formula, that is 180 degree plus angle of g of j omega g into h j omega g. So first the given system g of s is equal to s plus 1 by s square. So s value, substituting s value as j into j into omega wherever s is there in this equation 1. So first step is we have to calculate the omega g by equating magnitude to equation 1. So that is, in order to calculate omega g by equating to 1. So if you simplify, if you simplify this omega j g of omega g of j omega, that is by substituting j value as -1, we'll obtain root of 1 plus omega square by omega square, which is equal to 1, because we have to equate the magnitude equation to 1, which is, if you after simplifying and solving for omega, we'll obtain omega as 1.27 radians per second. Next is we have to calculate the phase margin using this formula. So substituting this obtain values in this formula, that is 180 degree, and angle of g of j omega can be obtained by applying formula, that is tan inverse of omega by 1 minus 2 into, this will go up, so minus 2 into tan inverse of omega by 0. So when you simplify for the further steps, we'll obtain tan inverse of omega 1 as 51.78 degrees. So which can be approximately equated to 50 degrees. So the given answer is obtained answer can be matched with the option B, that is 50 degrees. So the answer is B. And from this question we have learned that how to find out the phase margin by equating it to gain crossover to magnitude, by equating gain margin to magnitude equation to 1, and by calculating the phase and substituting it into the phase margin formula. Thank you.